A very good day to all. So in this lecture video we will be discussing about case study on advanced aluminum milling technology. So we all know about the milling process. So milling process is a process of producing components through milling cutter. So here the workpiece will remain stationary whereas the tool will move, and this particular case study is about machining of aluminium. So in the aluminium machining, the application of this aluminium machining is production of aircraft wings, aircraft engines, and also monolithic structural parts for commercial and military aircraft. So most of the parts of aircrafts are made using aluminium alloys since they have lightweight structure and high strength to weight ratio compared even to steel. So that's the reason for going for aluminium based alloys. So if you take an aircraft structure, it is a very huge structure. So monolithic part indicates that it should be produced from a single part. So such parts require very large machines in order to machine very large parts. If you take an aircraft wing or aircraft engine, it is a very huge structure, and to machine such huge structure, very high process capability machines are required. So problem with that is that, as you can see here, so to produce large parts you need large raw material. So here the billets are as large as 3000 pounds and 17 feet long. So in order to machine such hard parts, specialized machines are required. So what are the specialized machines are used is that here they are using a gantry style vertical milling machine. So here the workpiece will be hanging in the gantry. As you can see in this image, the workpiece will be suspended in the gantry and the tool will move over the gantry to machine these parts. So what's the problem associated with this gantry style milling machine is that they are very huge structures, and hence they cannot be enclosed in a closed structure. They are usually hanged in open areas. So when we hang in open areas, the major problem is that we cannot control the operating temperature. So the operating temperature varies with respect to the environment and the time of machining. So during the summer season, the machining temperature varies from morning. If you machine in the morning, it will be somewhat cooler, and as you can see, it is a very large part. The manufacturing of the very large part takes more time, maybe 2 to 3 hours. So within that time, imagine the temperature variation which can occur. So in the morning 9 o'clock, it may be around 30 degrees Celsius, but if you go for afternoon, if you take the midday, it may reach 40 degrees Celsius. So such temperature variation, what it does is that it changes the process parameters. So material will tend to expand. If there is sudden drop in temperature, material may tend to shrink. So the overall setting of the machine itself has to be adjusted from time and time to encounter these variations. And also, when the material is exposed to the environment, both tool and the gantry parts are exposed to the environment, and hence the degradation is accelerated. So this is the problem with this gantry style vertical milling machine. So by using the design thinking approach, we have to provide a solution to overcome this problem. So by empathizing, we can conclude that the problem here is that open nature of the machining process. So in order to minimize the open nature, we have to provide an enclosure, and also the temperature has to be controlled. So to provide the temperature control, we have to provide some cooling setup, and also the variation in the tool surface and the material surface has also need to be reduced. So these are the process by which the disadvantage of this machining process can be reduced. So how we can reduce this process, we will see in the upcoming video. Thank you, students.